in atomic power plants, at least when they are private companies that have a financial balance that must be clear. I had personal contact with the CEO of ENGIE, one of the largest nuclear producers and owning most of the Belgian stations. And they said really to me, nuclear for us, that's gone. We never will invest in nuclear any longer. And what they do is they invest in large-scale wind, mainly offshore on sea, photovoltaic panel fields, storage of electricity, well, converted electricity, load control, data analysis, and so on. That's going on in Europe. The next is the thermal power generation. We are talking now about thermal power, but about nuclear thermal power mainly. Many of you know this, but I just show it a little bit. The core of a steam power generation plant is a steam turbine, where you put in kinetic energy from high pressure steam flows that go through the turbine and get out, and they must be sucked out by condenser, so to say, by cooling. That steam turbine makes an axis rotate, and the rotating action drives a generator that makes electric current. So that's the core, that's the essence of producing electricity, having a flow in a turbine driving a generator. If you use wind, for example, PV, photovoltaics is still else. Here you see what we call the source and sink flaps of a generation system that needs a fuel cycle and that needs a sink for its waste. That happens in fossil fuel thermal power plants, and it also happens in atomic thermal power plants. In the middle, you see the core of it, the thing, that's steam turbine alternator. And then you have an enormous source flap of uranium mines. You must mill the material, you make yellow cake, then it has to be enriched to make fuel tablets and so on. That's the one side that's very costly, very extended. At the other side, you have waste, atomic waste, mine tailings, but especially, of course, you have the spent fuel that has to be stored for many years in water basins and to be cooled all the time. And that gives a lot of problems. You also may think about reprocessing the waste. This happening somewhere and some places still, but it's also a huge process. And at the end, of course, you also have to decommission the nuclear facilities. And finally, you have to decontaminate the area, and you have to store that high-level waste because there is no other solution. Here you see the picture of the economics and the efficiency of part of that cycle that makes nuclear power. You have a reactor and you have the steam that made there and sent to the turbine. So in the rectangle here, if you see my arrow, the rectangle here, this is the core, and all this is part of the flap, but just a minor part of the flaps. The flaps are much larger. Now you see that the minimum investment that you will need is $10,000 per kilowatt. Minimum investment, that is the experience we have with all those other stations. And the second point is that the generation efficiency of such a nuclear plant is 33% about, maybe 34 in the latest, but it's no more than this. That means that 1 kilowatt hour electric implies the generation of 2 kilowatt hour waste heat. So if you 1,000 megawatt plant has a 3,000 megawatt reactor, and 2,000 of that megawatt reactor makes waste heat. So this is the reality, and that waste heat, of course, you have to get rid of this, and it must be sent to the environment. Few examples of flaps. You have there oil rig, you have a refinery, you have coal plants. So all thermal power has that thickness of that huge flaps. And of course, you have also the nuclear flaps. And the picture down is the site of Fukushima, destroyed in March 2011. You see what an enormous site. And the cleaning that accident area and the cooling water stocks, that's a huge problem also, may cost, some independent estimates are between 500 and 750 billion dollars. Now, risk that shows related to atomic power are real costs. People think risk is something unreal, untouchable, so we don't take it into account. Accidents will not happen was the idea, and still is the idea of people who want to build such power plants. They start from the opinion an accident will not happen, because they know when it happens, they have done all the effort for nothing, and even not just for nothing, for an enormous cost to clean and to repair, etc. So risks are really real costs. Now, what do we do in our normal societies, especially in the West, is that when we have a risk, we go to an insurance company. An insurance company is always happy to receive your premium to be insured because they make a profit on this. But what you see in the real world is that no real big reinsurance company is willing to insure nuclear power. They don't accept those thick, fat premiums. They say, we don't need your premium. We are not insuring you because the risk is too high. This is a very important factor of the cost that always completely neglected, but in reality, it's there. So if you look at Japan, the whole atomic program, and this was an extensive one, more than 30 reactors, has cost more than the value of all generated atomic power. Now, what they do now to reduce the cost is to change the safety limits, and they are just dumping now tritium into the Pacific Ocean because it's too costly to clean it. So this is what we are doing. Okay, so the question is atomic power good economics? And the answer is no. It are bad economics. There are many economic financial disasters, not just that one in Fukushima. There are many others, smaller and larger. They request subsidies for building and operations. All is based on subsidies. Even the most conservative economists now agree on this point. And the subsidies come via direct grants from the Treasury. So it's your tax money then. Extortion of captive customers. They make pay the small customers in advance, even for building reactors. And then you have the price guarantees, like in Belgium, for example, and the UK. In the UK, at this moment, they are ensured that they will get for every kilowatt hour that the stations would produce at least about $12 cent, $14 cents, I think already, for a kilowatt hour. But in the market, they operate at this moment at the price of 5 cents. The real bulk market handles kilowatt hours at 50 euro per megawatt hour. So that's about $60 per megawatt hours. And that means 6 cents. So what happens is that the taxpayer in Belgium will pay, and also in the UK, the difference between the 14 and the 6. So it's all subsidies based. The excuse for draining the subsidies have been before that
Было обоснование, оправдание снижения
access to
субсидий,
atomic weapons. Uh,
доступ к атомному
since the
оружию.
oil crisis in 73, it's substituting for fossil fuels. And now, since the climate crisis is developing, we argue we are a solution for climate change. Now, that's also there all that time. Are atomic power environmental impact
Атомная энергия,
acceptable? The major impacts are
экологическое воздействие, приемлемо ли?
radioactive releases.
Мы говорим о радиоактивном
Accidents.
выпуске.
I get the noise from the Russian translation now. Sorry. During accidents, polluting air, and so on. Cooling water is an important aspect because now with problems with fresh water, we see, for example, in France, that in a hot summer, various reactors has to come down in power output because they evaporate too much of the rivers. They raise the temperature too fast. There's fish starvation, and also biocides are put in the lakes and in the rivers because of the cooling water use. Then you, of course, you have the radioactive waste, low level to high level. Reprocessing means that you are trying to develop a plutonium economy that's mainly based on breeders. We come to this, breeders are a failure too, and there are no valid technological solutions for waste, except what we do is storage in pools, hangars, deep underground. So it's a real intergenerational injustice. What it means is that the present generations, 50-year build power, if everything goes well and good, like we had in Belgium, we had good stations, so no big accidents, that discards the eternal waste to the coming generations. Okay, does atomic power fit with PV and wind power? This is a quite important question because we see and we observe that PV and photovoltaic, solar electricity and wind electricity is growing very fast. Solar and wind power is totally different from atomic power. It are natural currents without flaps, no need for cooling water, no major risks, limited environmental impacts. Technological development there is running like full. It continues. The prices continue to go down. Expenses per kilowatt hour generated are the least, and for PV decreasing all the time. Small scale photovoltaics and medium scale wind turbines on land built are applicable everywhere, affordable also for poor communities. For me, that's a very essential attribute, of course, because if we want gain, or if we want master the climate change issue, then we must do it worldwide. In Africa also, in South America, in East Asia, where people is poor, but we can afford that renewable electricity generation. Now, you know, electricity is the most famous XG1 top type of energy. You cannot have better than electricity. It's also desirable for stimulating community life. The point is that in a same integrated electricity system, it is observed already today and obvious, if you think about it logically, that atomic power conflicts with PV and wind power. atomic power tries to sell itself as a good bride for PV and wind power, but that's not true. Once we are in the same bed, they kill each other, and especially atomic power kills the renewables. So here we have some nice pictures, harvesting ambient currents for making that electricity with a wind turbine, and you have there also something that turns, like a turbine, a wind turbine, and that drives the generator. But what you see, you don't have source and sink flaps. Not for photovoltaics, of course. The light that you don't use for your cells remains light, simply. And also not for wind blowing to the turbines. You take out at maximum 2/3 of the energy, in practice less, but in theory 66% is the maximum, and the other wind just stays in nature. Now let's look at the costs. That's very important. The costs we express, and everyone now does. Also, we did it to start the practice very strongly in the report of renewable energy of IPCC that was
межгосударственной группе ГЭК по изменению климата. Это международная группа экспертов IPCC. Мы анализировали
method of assessing what costs 1 kilowatt-hour when all the expenses of the investment are calculated and paid. And you see that for solar photovoltaic, the price is coming down to 4.9 US dollar cents. Well, in large scale, utility scale plants. For wind on land, it's 3.3. For offshore wind is 8.1. You see that all those prices of renewables are below the cost range of fossil fuels. That's the gray band is the range of the cost price of a kilowatt-hour from fossil plants. Now, I found the numbers yesterday of the atomic power levelized cost of energy range, and this is from 14 cents to 22 cents. The source from this is a famous company who does these calculations for everyone globally in the world. It's Lazard. It's an American consultant company. And this is a publication from 2022. So the truth is that it's just cheaper. It's mainly cheaper to produce kilowatt-hour with renewables than with the others. Okay, the next argument is that they don't fit together. And for this, you have to have some view on what electricity is. Electricity is a transient phenomenon. Generated kilowatt-hour must be used within seconds. And when there is a demand, the demand must be filled within seconds. So it's a really transient phenomenon. This is a graph from 2013 from the IEA. IEA is not an organization that's hostile to nuclear power. Contrary, they support it very much. So this is the demand of a day, let's say. In the night we sleep, we don't need a lot, and then you have a noon dip, and then you go back. So that are 3 times the same load curve or demand curve for energy. Now what happens if 25% of your capacity is in PV? That eats a small part of the load. When it's 50%, it eats more. When it's 100%, and that is coming because it's so cheap to construct it, it is like this. Now this graph is from 2013, and at that time there was no talk about storage from PV in batteries immediately, and also not of redundancy. Redundancy means that you, instead of building 5 kilowatt that you need for your house, you just build 10 kilowatt. Why? Because it's so cheap. You say, okay, the full roof, 10 kilowatt. And that means then that this inroad of solar will be much larger. Now, if half of the load or more is eaten by PV, what's left over for nuclear? Nuclear cannot live, of course, on this type of demand curves where it has to stop half a day and then restart again. So the two currents conflict, and you see that the priority for the one ruins the business case of the other. If you give priority to the atomic base load, it is the renewables that have to be cut off because they could produce more, but the demand is lower. So all this on top of the load curve will be cut off. On the other hand, if you say, no, because we don't have any fuel costs, wind and solar come first, and they are the base load, what we now are become the base load, and nuclear has to fill the gaps that is left over from the renewables, then the business case of nuclear is gone. Now, what are the arguments in favor of nuclear is often it's the International Atomic Energy Agency that organized that deception, is that the models that are used in IPCC, we call this integrated assessment models, are so coarse that they don't see the conflict. They have numbers of a country, the production of it, and that one number for one country in those models. Of course, that's a yearly number, but that yearly number says nothing about that conflict. So they don't see the incompatibility of the renewable currents and the atomic power that is concealed in the models itself and then in the outputs of those models. And so that supports the flawed discourse of renewable energy, nuclear power, carbon capture and storage, almost as equivalent solutions while they are conflicting. So this is a deception, a fake discourse that is spread. Another important point is that there are millions of independent generators of own power in the future, and they are not served by the old grids, pyramidal incumbent grids, where you have, like in the picture, 4 large stations. They put power at 300 kilovolts in the grid, coming down to 220, 110, 50, up to 20 volts in your the system that we need are multilateral grids, smart grids that connect all those smart grids together of the community power, and that's a completely other grid development than the vertical one we have still today. Okay, I think it has made this clear that the two don't fit together. Question 4, are disruptive innovations in atomic technology likely? You all have heard likely about Gen 4 and Gen 5. So Gen 4 are the breeders, source of infinite power, always is said. Now, what has happened in the real history of breeders is that some accidents happened in breeders, like in the Fermi one in 1966 already, but even earlier already accidents happened. So they have been spending $100 billion in RD&D, so research, development, demonstration of breeders in the Western countries. And here are the results. USA, that partial meltdown in Fermi 1, has had as a result that the United States have stopped their development of breeders afterwards. Belgium, Germany, the Netherlands have been building for quite some years on a reactor that was almost finished, a breeder of 3 to 7 megawatt, and they just abandoned that reactor after spending at that time, 85, 4.1 billion euros. So that's a huge, today it would be almost 15 billion euros in money of today. France is, of course, the example of big nuclear experiments. They have built two breeders, one research breeder, the Phoenix 233 megawatt, that has been working from 1973 to 2004. Was an experimental, not for the grid. Then you have that Super Phoenix that was built as a commercial breeder. It has costed $10 billion at that time, 86. It has run for 11 years and produced 7.5 terawatt hours. It means a capacity factor of 7% instead of a capacity factor of 90%, what is normally expected to pay the costs, only 7%. And they stopped, of course, because it was a failure. Also Canada, Japan, UK stopped. The high temperature reactor, again, a story of accidents and ending, except one success is in China, but it's a recent one. They have a new plant on high temperature steam of 200 megawatt with two reactors that steam turbine is fed, and it started in 2022. Of course, about China, you never get real information about the costs, how much has it cost. But in Germany, the project failed completely, and on May 4, 86, that's 8 days after the Chernobyl disaster, they had a big accident, and since then they couldn't produce anymore and they stopped it. South Africa experimented. It's a country a little bit like Kazakhstan. It's not very developed, but it's quite developed. And after spending, I believe, $1.5 billion, no one was willing to join into their project, and they stopped and mothballed. So the next is fusion, the big hope. You know, the world, all countries together are working on ITER, a demo project in France, 10 million parts to assemble. Now assessed is the spending 34 billion. Presumably it will be more, and it will generate no single kilowatt hour. They even don't know how to get the heat out of that reactor. So the 500 megawatt transfer station that is built near the ITER is for feeding the ITER, just for putting 500 megawatt electricity in it for the lasers to keep the flow going. The successful small experiment of fusion in December 2022 was for military ends, had nothing to do with civil power generation. Okay, when we are talking about science, about innovation, technology, the quantum physics, of course, is the 21st century innovation and theoretical basis for many innovations. And you have two directions, one for evil and one for good. This is the evil, that's mega giga size. E is mc square, you know this. That's the basis of atomic bombs, of course. It's the first development of atomic energy. And after this, there was a big bomb proliferation, USSR up to North Korea. Since 1950, we have a deployment of atomic reactors of diverse technologies, absorbing almost the full R&D budgets from post-war up to the 1970s. No other energy got money for research and development except nuclear atomic energy. And the results are very poor. So incredible was the support. And just to signal you, it's not to do with quantum physics, but a similar hype that existed about atomic power is now constructed for hydrogen. This is a very similar hype. Then we have the micro, nano, more flourishing possibilities that are in quantum physics. And that's the ground of microprocessors, semiconductors, computers, ICT, new materials, etc., etc. The web and the World Wide Web and smartphones. I always say these are the impossibilities. When I was young I mean 40 years, this was impossible to imagine that it ever could be, but that has become reality. Every person almost in the world is now in his pocket a computer much stronger than the strongest computer you can imagine in the 1990s. So this incredible power electronics are very important. Batteries also are very, and PV, that's then back to electricity, converting light directly in electricity, is growing in efficiency and stability, decreasing cost by nanosciences, unbeatable by any other technology. So the cost decrease is not done. It's still going on, and it will go on. A small history, why then have that photovoltaics is not come much earlier into the market? Well, they were developed for the spaceships, you know this all, but however obstructed in civil applications. While they already were used 20 years in spaceships, in 1973, Nixon's energy strategy has no PV in it. And Reagan, when the predecessor of Reagan put some solar cells on the White House, he removed them and he aborted the PV budding when it started to bud and to small grow. In 2011, 2014, also in the EU, they preferred subsidies given to the big atomic plants in the UK, I told you about before, and they slashed the grassroots PV expansion. This is really happening in the EU by the EU Commissioner Almunia. In 2008, China started also in PV, but we didn't follow the policies of the West. We just went for it. And at this moment, we have 80% of the global PV market and 34% of the PV installations in the year 2023. Maybe now it's more. There is now a production capacity in the world, most in China, to produce every year 1,000 gigawatt. A gigawatt is 1,000 megawatt. That's one large nuclear station. But they are now able to produce 1,000 gigawatt per year in PV. And it's spreading globally very fast. For example, in 2023, there was 350 gigawatt, and some other sources speak about 450 gigawatt added. So to total of 1,600 gigawatt. And what is set as tripling will happen. It will be more.
Так что я думаю, что до 30-го года, наверное, эта цифра утроится, да? Идем дальше.
Before the year 2035, because in the year 2035, the whole energy systems will have to be changed already if we don't want to be killed by climate change. Given the 21st century experiences in all those atomic power plant projects in Western countries, at least, a construction time shorter than a decade is very unlikely. You have shown this before, and I've given you the numbers, the figures. The Eastern countries, South Korea, China, did realize some project on time. That's true. For a project in a nearby Eastern country, I would say you in Kazakhstan, look at Iran. It's not so far from you, I think. I've been there a few times. Seaside Bushehr there has one existing reactor. It's a very bad result anyhow, but we are now working on two 1,050 megawatt VVRs under construction. I assume that Kazakhstan is also candidate for a VVER plant. It started in 2016 and is planned to operate by 2025-26, but the information on progress and costs is incomplete. I have very little on this, but when I was taught in a course on combined heat and power in Tehran for all that leading staff of the Iran's regional electricity authorities from Shiraz, Isfahan, Mashhad, and so on. We spoke, of course, we were 2 days together, and we also spoke about the Bushehr station, and we were very critical on its performance and costs. We said it should produce 1,000 megawatt, but it doesn't produce 100 megawatt. I don't know if it's true or not. It's just information for you. It's an interesting case to investigate. Okay, we come to the conclusion. The technological reversals in electricity generation will occur. We will have that photovoltaic expansion. We will have that wind power expansion. So what's really happening is that we go over from a world from very cumbersome techniques with all those slabs on concentrated energy sources to direct harvesting of diffuse variable flows. And this is the final slide, and then I'm just within 1 hour, I think. The vision of the 3 main eras of energy use and related civilization. For me, energy is really the fundament of life. For you too, for everyone. Without energy, you can do nothing. So energy must be there before you can do something. And energy is also there before you can build civilization. And what type of energy? It were renewables and so on. We developed them up to 1,800. Then came that abrupt change to be able to transform heat into work, power. And we started to mining fossil fuels, all for free because we were manufactured by nature before. And that was the era of steam, combustion engine, big things. And now we go over to era 3. We have to go over to era 3 if we don't want to starve by climate change. We have to go over, and we can go over, because this is the technological future. This is the end of the lecture. There are 2 more slides just for reading for you at home. And the last slide, I give a small comment. If you really want information about the activities in the nuclear sector, the most recommended report is the World Nuclear Industry Status Report. It's all free access. You don't have to pay for it. Go to that URL. You can download the reports of the last 20 years. The 2023 report is there. It's 500 pages, but it's well structured. It's very informative and more correct than the International Atomic Energy Agency figures. Also, IRENA.org, also free access, gives you all information about renewable energy. Okay, this is the end. Thank you for listening, and I'm open, of course, for answering your questions.
Aviel, thank you very much for giving an overview of your vision and experience from Europe. So let me switch to the question and answer session, and I start with the questions that were posted in the chat first, and then if there are going to be people willing to ask additional questions, they're going to be welcome. So the first question, dear Mr. Aviel, please answer the question. Many lobbyists of nuclear power plants in Kazakhstan spread the information that the latest generation of nuclear stations do not need water for cooling the reactors, or need very little. How much more water is needed for the operation of reactors? of its third generation, and what requirements apply to reservoirs? I assume the reservoirs to contain cooling water.
It's 14 hours.
Well, this is a strange comment. It's not a reactor that needs water for cooling as such. In the reactor, water is cooked, and by the heat exchangers that are in the reactors, we call that steam generators. The steam is sent to the turbine. Now, I don't know about a proposal of making electricity without steam from a reactor. Even the thinking about fusion is all about making steam. How will they get the power out of it? I don't know. It's not, radiation is not going immediately to power, I think. I never heard about this. What I heard about is that lead-cooled breeder reactors, they don't need to change fuel very often. They argue, but none exists so far, that a lead core reactor breeder would be refueled only after 20 years or something like this. This is what I heard, but not about not needing cool. It's the steam turbine needs cooling water, and reactors cook water.
Aviel, thanks. Can I clarify the answer? The question is, do nowadays new modern nuclear stations need water for cooling? I mean, like the proposal here to build a plant near the Lake Balkhash, and the concern is about that it's going the waters of the lake going to be impacted in terms of heat, etc.
Well, it's the one slide that I've shown you with the reactor on it. It's very clear. The nuclear reactors, and this is because of safety, in general don't make very hot steam. It's only the high temperature reactor, and the only one exists now in China of 200 megawatt. All other reactors make steam of medium quality, and the efficiency of such expansion in a turbine is 33%. Also, the most high temperature coal, where you have very special expansion of steam up to plasma, has a maximum efficiency of 48–50%. From a steam system, you cannot get more out of it. And that means that if you have a reactor of 1,000 megawatt electric, you have waste heat of 2,000 megawatt. And that 2,000 megawatt has to be sent to the environment. So you have cooling then in one way or the other. And when you have a lake, they will pump water from the lake, put it in cooling towers. Otherwise, it would be too difficult. Take it on a cool place and get it out in a place much further for not heating the place where we take the water. But it will heat the water of the lake, and it will contaminate it. And likely it also will kill quite some fish. That's happening.
Thanks. So next question. I will read it in Russian, and I think translators will translate it to English. So, Mr. Aviel, ответьте, пожалуйста, на вопрос, будет ли МАГАТЭ спонсировать проекты по развитию атомной энергетики в развивающихся странах, и будет ли это для них толчком, ну, я полагаю, имелось в виду толчком развития. Interpretation. Aviel, are you getting interpretation?
No, I hear nothing.
Okay, let me just quickly summarize this then. So the question is to you, will MAGATE, I think, is International Atomic Energy Organization, will they sponsor projects on the nuclear energy industry development in the developing countries? And will it be will it be an impact for their development?
Oh, this is something that has been tried too before in the first major Gulf of construction. You have to visit the Philippines, I think, Indonesia, Brazil, Argentina, Mexico to see the failures of all those reactors. And I fear the same will happen. For example, I know they are working in Kenya and try to promote a reactor in Kenya, but Kenya has so many renewable resources in wind, but also in geothermal possibilities that we can do everything renewable within 10 years. And I don't see the value of spending lots of money and money on reactors that maybe never will work. That's my answer. This is false. It's a putting our model into Africa, for example, doesn't work. That was development aid, and I've been in those projects in the 1990s. We ship there our technologies that are obsolete, and we don't think of the interests of the people. We just think of interests of the Europeans and the Americans who can sell that technology, and this is a bad development. I'm very convinced, and we all will learn the lesson maybe again, but it must go much faster. The other technologies go much faster, are much cheaper and more adapt to Africa. So I hope we don't construct in sub-Saharan Africa those reactors. They are trying to sell one in Egypt and build one in Egypt too, I know. And that's the only one, I think, not in Morocco, I believe. Yeah.
Aviel, I see, I just found the translation. MAGATE is International Atomic Energy Agency. So the question is, do they sponsor projects for the nuclear power projects in the developing countries?
Well, they don't have the money to sponsor, but they do the let's say, discourse. They are bringing that fake hype to those countries. They pay clever students at university to make a paper on the possibilities of nuclear power in Kenya, for example. I got such a paper for review. That's why I know that they are working like this there. And they are working like this in all those countries. They just have, so to say, seed money that they distribute, and their discourse is completely flawed, and they know this, and they also influenced IPCC. And I was just there, so I've seen it with my own eyes. I know the people, and I interviewed even in April 2014 by the acceptance of the report of IPCC Working Group 3. I said what's happening here is flawed. They were saying the major barrier for nuclear is that people don't accept the risks. But why should people accept the risks if the big insurance experts, they really know what the risks are, don't accept the risks? Why should common people do it? So this is what they do. They negate the reality. They make studies for countries, and they say, like for Kazakhstan, they make a study of demand projections and supply projections, and they will say, here is place for a nuclear reactor, so you should build a nuclear reactor. This is what IAEA does. What they don't do is their other job. is avoiding that there is proliferation of nuclear technology and weapons. And that's more important. But we don't look at after that.
Thanks. So next question is, dear Professor, for a country abundant in nuclear resources, it is difficult to think about selling its resources and not utilizing them in its economy. What are other perspectives for these expensive resources, if not the atomic energy?
Well, I think, and I told this in an Almaty lecture this year in May, to that people of that fuel sector, you have that mines, you have also that the people who work on making that fuel ready for further processing, and you earn money from it. So it's a profitable business because you sell to others. And I said to all that audience at that time, don't waste your profits you have on the fuel cycle on building a station, because then you lose all your money and it will burn up for nothing. So now, as long as fuel for nuclear is requested, and I think in a civilized country like Kazakhstan, you can master this well. For example, the mines in Niger, or if it's Mali or Niger, I think one of the two countries in Africa, there's more problematic and likely those will close. So there is a stock of nuclear reactors that comes down every year because there are more closures than openings of reactors. But for another 30 years, there is work to sell fuel with profit. Don't waste that opportunity. Sell fuel with profit and don't waste your money. That's my advice to Kazakhstan. I don't pay taxes in Kazakhstan, so it's not. I'm not interested for the rest, but I advise this. Okay.
Okay, so there is one more question. What is the optimal solution then if renewables are not a 100% reliable as a source of energy? What is the optimal solution? Yeah.
That's no longer true. They are reliable as a source of energy because the technology is developing so fast, also for storage and for load management, that we can guarantee this. And you have contracts, for example, in that World Nuclear Industry Status Report, it's written that in California and near Los Angeles, the renewable energy sector makes a contract for guaranteed power delivery at $35 per megawatt hour. It means 3.5 cents per megawatt hour. That are contracts, you understand? Contracts with renewable energy generator, with storage and so on, with batteries, etc., and with other opportunities from wind and import maybe from other areas. And he makes a contract that guarantees this. So there is guaranteed power, and the technologies that are developing. And in Germany, we made studies of whole areas to render together that we could produce all their electricity renewable in a reliable way. Now, reliability is a particular aspect of power. And if you have a family, you know it, you have 3 levels of reliability in your house consumption. One is very basic, that is light and information that is needed all the time. You want to be connected to the outer world, your internet must work, your TV must work, and there must be light. That's basic, but this is a quantity of tens of watts. You understand? That's very low voltage that you need. Then you have the other ones that are driving engines like your refrigerator, your vacuum cleaner, and other rotating things. That's something of a few hundred watts, 500 or 600 or 700 or whatever. That's in that range. And then you have the very consuming end users. That's thermal. That's when you cook or you iron your clothes or you wash it in a machine that's driven by electricity heating of the water. That's the high voltage, high power you need. Now you can organize this that all the time you are absolutely guaranteed of 1 and 2 level, but maybe not of level 3. You understand? And then you have to put on your washing machine 10 minutes later or half an hour later. But this is all feasible to organize. And the big companies, NG in Belgium, where I talked to you about, there we are putting money in to control the demand, to control the flows on the grid, because they want to keep their business model of being able to sell power to end users, because this is the basis of their big profits they make. When this disappears, when all the energy like I am doing, I produce now already 2/3 of my electricity, but I'm producing next year presumably 3 times what I personally need. I'm a home producer. Then when many people do this, their model is challenged, and that we want to avoid by doing that large-scale renewables and then storage, management of data, and so on to keep in the market. So there is no real problem of reliability as such.
Thanks. I think to summarize your points, one of them is that renewables can be reliable, but the companies producing renewable electricity should have the storage capacity so that they ensure the stable supply of or equally stable supply throughout the according to the demand. The other point is managing demand, which is kind of not comfortable for everyone, but it makes sense from European experience. And I think I've seen in the slides you were talking about the smart grids and showing the distributed power generation, which is relatively new thing to our energy system. Mm-hmm. And I think we have one influential person in Kazakhstan, Mukhtar Jakishev. He was talking about distributed energy producing systems and the smart grids. Yeah, I think that's I see the connection over there with this. Yeah, if you don't mind, we we have a couple more questions here. Professor, what pros and cons you see for Kazakhstan in building nuclear power plant?
What you mean?
What pluses and deltas you see for Kazakhstan if Kazakhstan decides to build the nuclear power plant?
Well, I don't see advantages, so I don't know there are advantages in it. I would rather speak of disadvantages all the time. So it's very difficult to see this advantages. No, some people say yes, we produce fuel, so why shouldn't we also use it in a nuclear power station? But it's too expensive, too risky, and long term is a harmful future. Then you have your waste that you must take care of forever, for eternity. You read about shortening those times, etc., but that's also always about one small part of that waste. And then you have other wastes that last, like plutonium, for halving time, 24,000 years, We have some active needs for 1,000,000 years half-life. So this is enormous. That's eternity. There is no place anymore for such inflexible bulk power in a modern power system. This is the point. This is the future. It's like our smartphones make that all the sellers of that big computers can't sell them any longer. It's you don't buy a PC on your desk that weighs 20 kilograms, that takes enormous place while you have it in your pocket. Do you see a place for that big computer next to you at your desk with that zooms all the time with ventilators and so on? That's obsolete technology, so you don't need it when you have a smartphone or a laptop. That's the change in technology. If for example, atomic energy hadn't had that now 70 years of enormous subsidies in everything, and especially in research, in Belgium still, the whole budget of the federal government in energy goes to nuclear. So they have had all that opportunities. It's like you, a 75-year-old guy is coming to you. He failed always every year at university, and he come to ask to you, I need another chance, you know. Next time it will be good. But he has been failing his whole life. What are you going to do? You give him your money? I don't think so. You will say, go away and go rest somewhere else, but don't take my money.
All right. Thanks, Aviel. So the next question follows this one. What lessons Belgium, your country, has learned from having 5 nuclear power plants?
Well, we had 7.
You have 7. Huh?
Yeah, we had 7. The point is that now all those nuclear power plants are owned by ENGIE and EDF. ENGIE 80% of the shares and EDF 20%. They are now in French hands. It's so that CEO of ENGIE in 2011 talked to me and he said, we must get rid of nuclear. We must get rid of it. It's no future. It's go away with it. So that's one. Now, what was, of course, historically, if you look at it, we started in the 60s. No, we started in the 50s. And why did we start so early in Belgium? Because the first atomic bombs in the United States have been made with uranium of our colony in Africa, Congo, in Kazakhstan. They had their mines for uranium. And that uranium has been used for the first bombs. And that made that Belgium was a privileged, let's say, friend of the United States to receive the technology about nuclear. So we started a research center in very distant from in the woods. We started a research center. So we were in for nuclear. And the idea was that we would do the full nuclear cycle. We even have Eurochemic, was a reprocessing company, actually everything. But then we were eaten up by the French, so to say. We constructed together the reactor in Chose A. It was first a Westinghouse reactor in Europe, I think, that has been built in the 60s. And then Tractebel, who was the engineering contracting company, were clever people. They designed then the reactors for Belgium. And you must always tell the truth. They did it very well. We have a very clever group of engineering contractors, and our stations have been built. There was some cost overrun and some postponement, but this was not too much. For example, the start year was delayed by 2 years, but not by doubled or tripled like today. And the budget was maybe 40 or 50% higher than planned before. So, but this was all reasonable. And secondly, the stations have been working in a reliable way. And say the average load factor was between 88 and 92%. So that were, let's say, good stations, like you had in other countries. In Switzerland, you had good stations. You had in Germany some complete failures, but also good stations. Also in Sweden, you had it. Also in Finland. So we have a good experience on this. Not like the UK. The UK was a failure with AGRs, the advanced gas reactor there. But we were, so this was at that time a good money-making cow, especially because they were financed by the captive customers. And it were the captive customers who had a quite large rate for electricity, but everyone could pay it, so not the problem. So they were quite good. And that made Belgium a real nuclear country. But in 2003, there came a law by the Greens, mainly pushed by the Greens, who decided that we would phase out, a little bit following Germany on this point, all reactors after 40 years of service. So what we are going to have now, 2025, from the 7 reactors, 5 will be closed. And the 2 other reactors that also normally would go out of service, they are a life extension of 10 years. So they can continue to produce until 2035. And this was again a Green minister from the other color, I think, than the other Greens, who decided this and who's, but ENGIE said, we don't want to continue our reactors. We want to close them. We want to get rid of it. But we are very strategic negotiators. So we knew to negotiate the following, that by paying 15 billion euros to the government, all the nuclear waste problems went to the government. So ENGIE is freed of all the nuclear waste. That's one. That's the most important they won. And secondly, they won that contract for differences that starts now at, I believe, 78 or 80 euro per megawatt hour that they produce. They have that minimum guaranteed price. It means, like now going on in the market price is 50, that the state must pay 30 euro per megawatt hour produced to ENGIE for producing atomic power. It's so crazy that a Green minister signs such a contract that impoverishes the citizens, and mainly the poor citizens, small captive customers, because the middle class and rich like me, we will escape and go to PV, and we will not pay from the grid any longer. So this is a position that's very bad. In my argument, we did not need that new reactor, so we did not we did not have to ask ENGIE, please keep your 2 reactors open. ENGIE wanted to close them. But we got a huge price for keeping them open because of our stupid government, really stupid government. And the future generations will pay for this. It's clear, I think.
Yeah. This is a very long story. I actually didn't know that Belgium had nuclear power technology, because they had they owned uranium mines in Congo because of this. They had the colony over there. So I think you're almost responding to the question, the last question in the chat that we have here, and the question is how much Belgian government allocates for supporting nuclear power plants annually? You have the number?
Well, it's I don't have it for me, but two guys have then. That's of course, Engie is a very strategic and clever agent. So what they did is they did not sign that contract before all was put on paper legally, etc. And I believe it is 2,600 pages contract, 2,600 pages. And I personally, I did not read it because I'm working on other areas now. But it's two people who are also part of the grassroots community and the environmental movement. They studied the 2,600 pages, and they have estimated that at least it will cost. Belgium is not such a big country. At least it will cost 1.5 billion euros per year to pay that surplus money that I just explained, and that filling the gap between the guaranteed price for Engie and the market price. So for making that gap would already cost 1.5 billion euros per year. And it could be more. If the gap becomes larger, it's each time a few hundred millions more. This is what we expect in the future from nuclear. And then, of course, we have to pay for all the care for nuclear waste now. Before it was the companies who had to make a fund, and they made a fund of, there was a savings already of 15 billions. And so they had to pay another 50 billions. And what they will think, oh, and they will wait it. And no, once the contract was signed, they immediately paid the 50 billions to get rid of that waste forever. So they are very strategic and clever. But who is going to pay for this? This is not done. This is not done. Then we have that decommission and so on that's still going, must come on. It's a bad, let's say, heritage. We have a very bad bequest from the nuclear experiment.
This is probably what we have to expect with the nuclear power plant in Kazakhstan if we build it. So there's going to be some portion of subsidy and or guaranteed price for the sponsor, and somebody, government or the taxpayers will have to pay the difference. That's what we have to fear about. And the other point that you're bringing, the fund that I think that's the equivalent to this liquidation fund that we have in Kazakhstan, the requirement under the environmental regulations that the companies have to create this liquidation fund for whatever activities to clean up later sometime. And if they get out of business, then the liquidation fund is the only thing that the government will have in their hands to manage the cleanup of the mess that's going to be left by the industry. Aviel,
look at Japan on this point, you know.
Yeah, we the taxpayers going to pay.
Yeah, yeah, pay.
Yeah,
in Japan. Yeah.
I think I've read all the questions from the chat, and I think I can open the floor to others who are willing to ask questions here verbally, because I was talking too much, so I let people talk. Feel free. Yeah, ML. Yeah, you can turn on your microphone. I think. Can I press this button to suggest you? Yeah.
Can you hear me?
Yeah, Muradbek,
Hi, yes, thanks
Professor
Stan
Lajibayev.
for inviting me. Good conversation and interesting insights, Professor Aviel. My question is twofold. One is that your information mostly comes from the European context, while we have China and South Korea as two contenders for the project here in Kazakhstan. And so if you have any information on these two areas. The other is that if economics doesn't make any sense, which most I agree with you, then why do we have these countries really interested in building more nuclear power plants? What would be your reasoning to that?
Well, on South Korea and China, I did not prepare for this, but as I said, is that famous report I referred to, the World Nuclear Industry Status Report. The title is clear. It's the nuclear industry status. Every year we put this, and there's a lot of China there, and a lot on Korea. For example, South Korea, KEPCO, they filed a loss of 25 billion last year in 2022. And well, the report is from 2023. And that adds to their total losses of 100, it adds to up to 149 billion, KEPCO. What is a state-owned utility? Yes. Working with nuclear stations. So just an example, because you said South Korea. On China, it's very difficult to get numbers about costs, but they are the only ones who really are expanding nuclear power these days. And so far, there is no information of real big accidents or whatever. So this is possible that we push this. China is pushing everything. They are also pushing photovoltaics and wind energy, and this will come out later. What will win? I know what will win, and China will then reduce its expansion, I think, in nuclear power. But they are now expanding. But for good information, just go to these reports, download them. There are chapters on China every year, special chapter, because China is really the last 10 years the only country that adds stations to the whole system. For example, in 2023, there were 407 reactors. And it's written here, over the 2 decades, 2003 to 2022, there were 99 startups and 105 closures of nuclear plants. So let's say 6 disappeared in total. The 49 startups came from China, 49, with no closures. So China is really a significant element in the survival at this moment of the nuclear industry. The economics are always based on subsidies. There is a colleague who was at the Nuclear Regulatory Commission of the United States, and he was a lawyer, and he made an article in Nature about this, and he said, I haven't seen any nuclear station in the United States that's not subsidized, mostly by the customers, captive customers who pay too high bills. That's one. And this is also for others. It's subsidized. And also in Kazakhstan, we will make a regime where they are subsidized. In economic terms, and you can look back at slide 14, where you have the levelized cost of energy, it's 14 to 22 cents where renewables are all, the good renewables are below 5 cents. And they will set the price in the future on the market at 5 cents. So they never can compete with electricity that costs 14 to 22 cents. So if we want to survive, we need subsidies. And colleagues that before wrote leveling papers and nuclear we need, etc., are now saying we only get nuclear when we are willing to pay for it by subsidies. That's the economics. You agree?
All right. Thank you, Aviel. Do we have more questions, or we can start getting? We can start finishing.
Здравствуйте, можно вопрос задать?
Давайте, Арман. Ваш вопрос?
Допустимо ли построить АЭС в том случае, если, например, на сегодняшний день правительство приняло решение о строительстве атомной электростанции на Балхаше, то есть на берегу Балхаша. В будущем, если высохнет Балхаш, вот на таком месте допустимо построить атомную электростанцию? То есть мое предположение основано на том, что в будущем Китай строит канал. В будущем вода река Или будет переправлена на этот канал, чтобы обеспечить внутренние потребности населения Китая. В этом случае вполне возможно, что Балхаш высохнет, как и Арал. В таком случае допустимо ли построить атомную электростанцию без воды? Понятно, да, содержание вопроса?
Батор, вы переводите, да, вопрос?
I cannot say anything because it was all in Russian, so I can't understand.
Aviel, have you heard the translation?
No.
So let me quickly summarize the question for you, Aviel. So basically, the question from Arman was that since our Kazakh government is trying to build a nuclear power plant on Balkhash Lake, and there's a concern that China is going to take the water from the rivers that feed into the lake, and so the lake Balkhash potentially could disappear, or the amount of water gonna decrease. So that's going to be the risk for the lake and for the nuclear power plant. Is it acceptable, reasonable to not consider the risk like this?
No.
Арман, я надеюсь, я правильно передал. Okay, go ahead. Sorry.
Well, I must argue with a little band in the past. So I came into that nuclear debate on demand to testimony about combined heat and power. And then I saw the big companies, they were very arrogant but also very strong. And they said, that's what we want, and we will do this and that. And there were some questions. And so I intervened and I said, I'm sorry, but you are wrong on this. And there was a very technical issue about discounting. I said, that's not true. It's like this. I came from Stanford. I have learned there how to analyze projects and how to make decisions under uncertainty. So in 81, I was there as just a freshman. In 82, I was asked by the organizer of the hearing sessions to testimony about nuclear. So I made a model and I did some runs and etc. But the major point in which they had to recede in their coming up with their proposals was that I showed the whole public of that hearing session that the methodology that we used in making decisions about such an important issue like building nuclear stations was childish, was so poor, it was so nothing that you really needed a serious analysis before you take such an enormous decision. And we were so ashamed that we could not answer anything. And you know what their answer was? They wanted me to leave the room because I had no right to be there, they said. And another guy phoned the minister, and the minister immediately answered to them, he is my delegate, he shall be there. You understand? That's their tactics then. They don't play the issue, they play the man or the woman. And this happened. And because of that event, their proposal was not approved. Otherwise, we were starting to build that 4 large-scale nuclear stations after 82. And then the postponement went on and the discussions went on. There was some in-between agreement with France on shows B, 1 and 2. I don't give you the detail. But then came Chernobyl in 86. And so the case for the nuclear station fell apart. And they have never been built. But my arguments then were 2, as I said in the slide. One was the poor methodology of making a decision. And this is, if I hear this, that we don't look at such kind of risks, that there would not be enough cooling water, or what's happening with the possibility of cooling. You have to consider everything and all the risks. And this is, compared to a real accident, a small risk. But we also have to look when a real accident happens, how are you going to counter this? But generally, we have some idea of, and I have time to tell some story on this. In my work and in my life, I met one of the real proponents of nuclear power in Belgium. He was a Monseigneur, Catholic Monseigneur. Gillon is its name. He has published books. He was elder than me. He was trained in Chicago. He even worked together with Fermi in Chicago, he said, in the first reaction. So he was a real, but what he learned from 3 Mile Island is that they underestimated the risk of the creation of hydrogen. The estimates were that there was only a 4.5% quantity of hydrogen formed, and in the reality we observed it was 45%. And he was heavily pro-nuclear, but he was a honest person, so he went around on every nuclear congress. He said to his friends, we must be careful about that hydrogen that comes from the tubes of the fuel. You know, this is zirconium that evaporates and makes hydrogen. Because this is explosive, it's very dangerous. Now, what has happened in Fukushima? They phoned me in the morning on Saturday, and they said the reactor exploded. I said, a reactor cannot explode. It can melt, but not explode. Yes, but there are explosions. And then I started to think again, yes, that the hydrogen, of course. What did they do in Fukushima? They stored the spent fuel in the reactor building. And all these huge explosions came from that hydrogen that was formed. So how do that sector handle risks? They knew it. One of their big people told them after 3 Mile Island, take care of this danger. They didn't care. Now, what we've seen in Fukushima is that by a natural accident, such a reactor can lose control because of that water coming in. So what must you do in new reactors is the control center must be doubled or tripled outside the reactor area, 2 kilometers or 3 kilometers from it. The diesel generators in case of danger, they must be outside. There must be a cable too. Do they do this in the existing stations? No, they do nothing about it. And this is the lesson of Fukushima. Be careful that you don't lose control. But they don't react on this. The sector is so self-confident that a new accident will happen somewhere, sometime, in an aging. And this is why Engie wanted to get rid of its stations too. They said they are also guaranteed if something happens, it's all on the state. They are not responsible anymore. You understand what I mean? And also in Kazakhstan, I hope you have a very deep, complete analysis of that proposal. You need this.
I can hear what you're talking about, Aviel. That's about distribution of risks, and it's very important that government and the country shouldn't be taking risks upon itself, but and leave the companies only with profits. That's how I understand this.
Yes, but also in making such a decision, the government should have a very extensive, public commented, discussed proposal of what are the options for our future supply of electricity in Kazakhstan. That's the main question. It's not station or not. The main question is, how do we get electricity carbon-free next year, following years? How do we participate in that world movement? Is it by building a nuclear station, yes or no? And all the aspects related to that nuclear station should be in it. And all the aspects related to wind turbines, etc., should also in it. And the birds eventually that may be harmed by it, that you build your turbines not in an area where the birds pass, etc., etc. Everything should be. And this should be considered in a time sequential thinking process, not a scenario. Just scenarios is too simple. You must take a time sequential process. And that needs experts who know how to do this. And the whole assessment of IAEA, and I analyzed this in one of my articles that you also can find on my website under the stack atom, under publications. It's about how do they do a sustainability assessment. And you know what the criteria for IAEA are? If the ones respect our rules, they are sustainable. Yeah, that's easy, huh? I am a good person if I respect what I say, what is good. This is so simple it is. There's no science, there's no honest practice. You don't do it like that.
Yeah. So we need a wider public discussion and consider different other options in addition to nuclear.
Certainly.
And true experts involvement.
Yeah, independent persons is very important.
Independent, yeah.
Yeah.
We often have people who are dependent and provide their opinions as if they are independent. Yeah, that's a different reality here. So I think we have the last question, and we should finish. The last question in the chat from Asiya Argalieva was why the biggest banks and financial institutions increase their support for nuclear energy nowadays. And she provided the link to some news that says global banking giants pledge support for nuclear energy.
Well, the point is that I also read something in the newspaper. I didn't see the detail. It's not support. They want to benefit from the vacuums in the United States. And Google, I think, does it, Microsoft. Bill Gates, he was telling 2 years ago that he would go fast building a small modular reactor, but he already finished in the meantime, you understand? But they want to make use of the pressure to do something on nuclear, to get the nuclear power exclusively for them. And of course, that makes even logically some sense. And they need continuous power from megawatts, maybe 100 megawatt continuously, and that nuclear station is intended to produce that nuclear power constantly. But if we will hear the price of 20 cents per kilowatt hour, I think Microsoft will look for a contract like the one I told you about in California, where they get it for 3.4 cents per kilowatt hour, guaranteed power. So this is a whole, let's say, dancing around profitable issues. I never trusted very wealthy people. And I in my life, I also met something rich people. And I had a small company, so I thought they will help me. But they don't help you. They just try to exploit you. And this is also with Google and with Microsoft and whatever. They look for profitable issues. And maybe yeah, they find it in a very, very highly subsidized nuclear project. But in the United States, there's no company who is willing to accept almost for free the whole budget for building a nuclear station so far. And there's no company who is allowed to continue. Life extension is allowed until 60 years. And half of those stations have been closed before. Even in the operating costs of those older stations are so high that we prefer to close it because we can't compete at this moment in the market. So this is typical also. You only use, of course, in a scientific analysis, testified data. You must use data. And I once more refer you to the World Nuclear Industry Status Report. You will be amazed if you open this, how much very practical, tested, and year after year, bringing up again all that information on the sector. And I'm sure there will be a chapter on the USA, not on that latest newspaper news of yesterday, but it's maybe a fire brand and it's gone then. Do you hear from the SMR that Bill Gates is willing to build? Do you hear of the SMRs in the United States? I heard about it. NuScale was the most advanced project in Utah. They were the first going to build SMR, and then the CEO tried to get money again for it, and the cost price would be $20,000 per kilowatt construction. And so they filed for bankruptcy because his words were, if you are riding a dead horse, it's better to dismount. This is Sioux wisdom, but this is true for nuclear too.
Thanks for your insights, Aviel. It was quite a different point of view than what our government and many supporters of this nuclear power plant initiatives are doing in our country. Yeah.
Yeah. Yeah, that's it. It's a very, very hard fight hill up, but I also will remind you of my experience in 1981. When I came in the room, there was one sitting next to me from a public company, a director of a small public power company. And when he saw me, he said, don't make an effort. It's all lost. The decisions are taken. We will build at 4 stations. Don't make an effort. And I said to him, well, you are old and I am young, and we will see. So at the end, we won. Don't give up. Don't give up. It's a bad decision for the country. It's a bad decision for the people. So you must win this. Not for you or for I'm the best. No, no. For your country and for your people, you must win this, that we don't build this.
Good. Thank you very much. Now, you're telling us that you are old and we're young and we should oppose.
You have to do it.
Do the same what you've done. All right.
Yeah.
Thanks. Thank you everyone for joining this video call, this conference call. And I will, Professor Verbruggen, thank you very much for your sharing your knowledge, your experience. It was quite different from what we've seen.
It are facts versus stories and this. Okay, thank you, Dustin. It's pity that communication went not so good with my slides, but yeah, we will see. Okay.
It was good enough. It was good enough. Yeah.
Yeah. Have you seen me? No, I don't think you have seen me. Okay.
I could see you and I could see your slides. Yeah, there was some technical difficulty on our side, but at least we had questions. We answered the questions to a degree we could. And we thank everyone for participation, and we finished this meeting. It's exactly the time.
Okay. Okay, thanks.
Yeah, you got to do other work and I have to switch to other meeting. Yeah, so cheers.
Okay. Cheers.
Bye.
Bye.